The Euclidean algorithm. In number theory, they say maths is the queen of sciences and number theory is the queen of maths. Now, what we're going to do is explore the Euclidean algorithm. So, what we're going to do is, first of all, look at what an algorithm is. It's a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. So, by doing lots of iterations, we will solve problems. Previously, you discovered how to deal with number bases and the process of calculations involved in this, and prior to this, you explored how to represent numbers using the division algorithm. Remember, you were trying to represent it as the divisor times how many times it went into it plus the remainder. So we shall now extend these skills and techniques to find the greatest common divisor of two integers. An efficient method of computing is processes named after the Greek mathematician Euclid, often called it Euclid's algorithm, but it's called the Euclidean algorithm. The greatest common divisor is the greatest common divisor of two integers a and b, where at least one is non-zero, and it's denoted by the positive integer d. So what it means is basically the largest number that can go into them both, that can divide into them both, and you can't have a zero there, okay? Find the greatest common divisor of 42 and 78. This is not how we're going to do it, but I'm just using it as an example. So what you would have to do is think of all the numbers that go into 42, which is easy enough to figure out. And then the positive divisors of 78, a little bit harder, but still easy enough to do. So what you'll find is you've got common divisors of 1, 2, 3, and 6. So the greatest common divisor there is 6. Now we can see we could figure out every single multiple and see which one goes into them both, but obviously bigger numbers, that's not practical. So it doesn't make sense to write every factor out. It's not very efficient, and the Euclidean algorithm, the steps involved to do this, help us make it far more efficient. So the greatest common divisor, GCD, can also be found using the division algorithm with a remainder of 0, and that's what you're going to explore in this part. So let's go back to the question 42 and 78, and we set it up like the division algorithm before, but it's a little bit different. So what we do is we always put the large number is what we're going to see how many 42s go into it. So you always have the largest value to the start on the left-hand side, and then how many 42s are in it is basically what your divisor. So it's set up the same idea. So you'll have 142 there, and you'll have 36 left over. The difference is when you were using number bases and so forth, it was consistently the same number all the way down. But we don't do that here. It's not the same divisor throughout. We're going to go diagonally. What I mean by that is instead of having, let's say, changing to binary and having 222, we bring the 42 down. So then you have how many 42s were in 36? 1. And what's left over. And then diagonally again, you bring down, and how many 6s are in 36? 6. And what's left over. Now, in the previous page, it said when the division algorithm has a remainder of 0, when your remainder is 0, that's when you stop. And that means that the greatest common divisor of this is actually 6, which we found in the previous page, but we can do far more technical and almost like a computational exercise, okay? You can also class the greatest common divisor as the highest common factor, okay, but we normally say GCD, okay? So let's try this one. So 13 and 4. So you put a large number to this side. How many 4s are in that? 3 and 1 left over. What do you do then? You diagonally bring the 4 down. And how many 4s are in? And you bring 1. 4 times 1 is 0. When you get to 0, that is you finished. And this is your greatest common divisor. Nothing goes into 13 and 4, it's 1. So some people get confused about which number to take here as the greatest common divisor. Nothing went into it, it's just 1. It's actually this number here that you brought down. But the easier way to know is it's the number that's directly above the remainder being 0. Okay, so that is the greatest common divisor. That's got a special name when it equals 1. It's called relatively prime or co-prime, and this is when at least one of them is non-zero, and when you find the greatest common divisor is 1, it's relatively prime or co-prime. Okay, so let's try bigger numbers now. So 252 and 140, you put the big number to the left-hand side. You can't get 2 out, it can only be 1. And what have you got left? 112. Then diagonally bring down 140 and 112, and then you can get one of those, and then you've got 28 left over. Diagonally bring the 112 down, and then what have you got? You've got 4 of those, and you've got no remainder. At that point, that is you finished. So what do we do? Remember, we get the greatest common divisor by the number that's directly above the 0. 28 is the largest number that goes into both. Okay. Even bigger. So you might want to start using a calculator. 2 of those is almost 4,000, so you can't get 2 out, so it's 1. So you can use a calculator and then take one of those off, see what you've got left, diagonally bring down. You can clearly only get one of those. Diagonally bring down. You can get 6 of those, and then diagonally bring down, and I hope you can see you can get 2 perfectly of those with no remainder. That means we're at the end when you get r equals 0. So the greatest common divisor is 132. I've put a star here to emphasize if you're not quite sure which one it is, it's the number above the 0. You can use it in interesting reductions and fractions as well. So if you were asked to use the algorithm to try and figure out this problem, then we're going to do the same thing, largest number to the left-hand side. So then that can go twice. I'm not doing this in my head. The calculator would tell me this. I can get one of those out, what's left over. Diagonally bring down. How many? I can get 3 of those with that left over. Bringing the 4096 diagonally down, I can get 1 of those. Bring the 3328 down, I can get 4 of those, and 256. And then lastly, I can get perfectly 3 of those with no remainder. When it's no remainder, that means that I have stopped, and it means that I can get my greatest common divisor, and it's 256. You either get it from here or here. We're not finished though, because the question at hand said use that to try and reduce this down. So what it means is 256 goes into both of those numbers. So now I'm going to divide both of them by 256 and get my answer. You and I both know if you put that in the calculator, it would do it for you, but I'm showing you how you can use it to simplify a question. Okay, it's your turn to try. So what you're going to do is try and figure out something relatively prime. So you're trying to show that the greatest